Welcome back to RSA Conference 2021, live from Virtual Broadcast Alley. I am your host, Matt Alderman. Joining me for this segment is Ganesh Pai, CEO and founder of Uptycs. And welcome, Ganesh. It's good to see you again. We've had you on a few times, and you and I go back a little way, so it's a pleasure to have you on.
Likewise, it's a real pleasure to chat with you again, and I appreciate you having me on the show.
Yes. We're going to talk about the new perspective on cloud security resiliency. And my first question to you is there an old perspective on cloud security resiliency?
That's an interesting one. Of course, apart from the choice of wording, what is interesting, at least the way I see it, is that cloud itself is fairly resilient. As you know, that it's everything aggregated by one of the three hyperscalers of new newcomers. But when it comes to security, it is actually left to the individual organizations. The cloud providers themselves don't mandate, and that's where there are new approaches and new things that you can look at to understand whether it's your posture or what your workload security looks like.
Yeah, having spent a lot of time in application security, container security, and in this migration to cloud, right? I've tried to keep track of all the new services in Amazon, for example. I mean, there's new services coming up all the time, and they're providing more and more telemetry. But to your point, how do I integrate all that telemetry in and really build a more comprehensive security program when I'm running in cloud? Because you have CloudTrail, you have CloudWatch, you have the different services, whether you're running container as a service, you could be running Fargate. There's so much complexity in the cloud. Bringing all that data together is not easy.
That's right. If you were to look at the sources of telemetry, and if you were to try to come up with an approach to say, what does the telemetry mean and what can I do with it? You can think of the potential work that you can do on the telemetry to draw insight into four different areas. One is, what can you do proactively? Think of it as if you've got various standards and benchmarks such as CIS and NIST telling you that if you do things, have you done it right way? So that's one part. Then there is reactive security, which is your ability to quickly understand if someone's changing a cloud workload, what does that change mean, and what can you draw from that conclusion? Can you draw from that behavioral change? Is it with malicious intent or not? Then there is the ability to understand things based on how the past was. So you can think of it as a predictive approach where you're looking at baselines and deviations from baseline to say, is this normal or not? And then, of course, you can always put guardrails in place and do protection, right? So if you think of it as these four areas that you want to do, proactive, reactive, predictive, and protective, then the question is, what sources of telemetry are you going to rely on to make sure that what you're doing is fairly robust and reliable and gives you that visibility? And to that end, to answer to your question, AWS provides data, so do all other cloud providers, but they put it into three buckets. Everything at the end of the day either falls into a config or it falls into a CloudTrail activity, which is the behavioral change of the cloud. And then there is interactions with the services which result in flow logs, right? So if you have these three pieces of telemetry for the gamut of services that AWS provides, you should be able to do meaningful security across all the services that you procured from AWS. I know I said a lot. Happy to zoom in and double click.
Yeah.
But I'll pause you for a second.
Yeah, let's do that. So proactive. Let's think about that for a second. Proactive is setting up the right configurations for the different services or infrastructure that you're running. And ways that people would validate that would be, maybe a cloud security posture management solution, right? I mean, that's one way to do it. You also have code coming into that environment, right? And that's all part of the CI/CD pipeline and all your code and code checks and even some of your infrastructure that's being spun up as code, right? So let's double click into that piece first, because what I'm curious about is how is Uptycs actually helping in some of that proactive, right? That the early stage of how do you actually help protect some of those areas?
Great question. You can think of it as two parts. When you use the services of a cloud provider, either you're procuring services which the service provider gives you, as in a database service or a load balancer or a caching service, and then you're buying something which is very fundamental. You're buying infrastructure services, as in compute and storage, because you plan to run your own software, which is typically encapsulated either in a virtual machine or in a container and then deployed. So when you engage with the cloud provider, you have to have visibility into what's happening from inside the virtual machine, and you need visibility from what is outside at the cloud orchestration level telling you. CSPM gives you the ability by looking at the cloud configurations and then using reference standards such as CIS or NIST to tell you, have you done your basics right? Are your configurations sane, and are they telling you that you've got the check boxes so that proactively you can fix your findings and get a measure that my cybersecurity posture is good. You can do the same from actually inside the machine. There's an equal set of standards. So if you put the practices in place to get both visibility from inside the virtual machine of container runtime as well as from the cloud provider, you then have the ability to formulate a measurable thing to say, what is all this telemetry telling me based on inside and outside?
Yeah, so it's correlating the hosts that are running and the service configurations more into a centralized view. We had an interview yesterday. We were talking about some of the issues in certain Linux packages, for example, right, which are potentially running by default because it's part of the distribution, right? If you don't want those services running, you have to validate that those services aren't installed or not running. That's more inside, to your point, the virtual machine inside the box versus how I configure an S3 bucket or how I configure an ECS or an EKS instance, et cetera, right?
Correct. And in both places, just the config and deviations from config best practices tell you a lot, and just doing these proactive checks help you improve your, it's at the end of the day, cybersecurity hygiene, if you will. But if you look at these places and, tighten up your hygiene, there's a good chance that your resiliency improves tremendously in doing so.
Absolutely. Now, let's go to the next one, which is the response, the reactive side, right? Because when I see a drift in a configuration, it could be, the developers rolled out a new piece of software that maybe changed the config. Somebody went in and changed the config manually. Now you're outside of that baseline, that policy that you set. How do you react to that in an automated way? Because these things are happening potentially multiple times a day in cloud based on how people are deploying software. So then how do you, based on that drift and based on the telemetry that you're getting, how do you react to that in a very effective and efficient way?
Great question. And this gets into the second part, because if the first one is using well-known specifications to establish a criteria to say if your hygiene is good, then despite your best effort, how are you going to react to behavioral changes? When there's a behavioral change, to your question, you really don't know whether it's got malicious intent or not yet, but you have to look at the data, look at the context, and draw that conclusion. In order to make that happen, both cloud as well as your runtimes, back to the prior question's analogy of, you've got your virtual machines and containers where you're running your software, and then you're using services provided by AWS. In both cases, the operating system tells you about the behavioral change by emitting data saying that people are logging in, new software has been launched. In a similar manner, the cloud providers today, they provide you what's called as audit trail data, very specifically using the terminology of AWS, it's cloud trail logs. Yep. What these things tell you typically is that after you did a configuration, what were the behavioral changes in the cloud? Did someone start a virtual machine? Did someone go and make a change to a S3 bucket? And as a result of this, there is additional context, which then tells you whether this change in isolation is benign or it's as tied to like other sequence of things which might have happened around it, that they might be like malicious intent, right? So the ability to do a detection and response based on this behavioral intent. Traditionally it's EDR as applied to Linux virtual machines. It could be cloud detection and response as applied to the CloudTrail activity.
Yeah, somebody will call it XDR and include CDR in it, right?
Exactly.
So yeah, we'll end up with another DR term at the end of the day.
Exactly.
How does that tie into predictive now, right? Because behavior, right? You just said it, need to monitor behavior to figure out whether it's benign or malicious. But then how does that drive a predictive discussion? Is predictive more on the left side of the dev process to look at what a potential change is going to look like and then analyze it against the existing infrastructure or what that change looks like? Or is it predictive within the runtime environment? I'm curious how that predictive layer comes in.
That's a great question, and there's potential to do it both ways, as you just alluded to. In the first context, especially when it comes to cloud workloads, unlike traditional endpoint workloads, they tend to be more homogeneous in nature. There's typically a controlled environment where you might be using your CI/CD cycles, and you know specifically what kind of binaries you're going to deploy and what kind of outcomes you can expect. So one simple way is to track, because the realm of what's known is very well controlled, specifically in these cloud workload deployments. You can create a list, whether it's of hashes, configs, and track a set of things and say, when something new is being done, is this something expected or not? Wherein effectively what you're correlating is you take a CloudTrail change or an operating system behavioral change and say, is this supposed to happen or not? And what you're comparing against is what your engineering or your development cycles told you. Mm-hmm. On the other hand, what you could also do is, to the other part of what you said, is look at the last 30 days of behavior. In a cloud environment, you can see what's the normal when it comes to who are your system administrators, when do they log in, what services have been activated. If things have reached a certain stage and you're providing services, you know that your baseline is such, and you can collect pieces of telemetry. And then when there's the next change coming in, you can say, is this deviating or not? The same can be applied from inside the operating system behavior. Processes being launched, software being deployed, the packages that you have, users, you name it, even socket connections, you can keep track to say, what are the DNS lookups which are done in the last 30 days? There might be a few thousand, 10,000s, 100,000, but it's a list that can be compared against, right? So basic statistical deviations from either what you think is normal or deviations based on your historical runs, both allow you to get some baseline behavior and detect deviations to say, hey, is this potentially an outlier or is this truly an anomaly?
Right. And I think one of the challenges in certain infrastructure, so let's talk containers for a second, because getting that level of information out of the container is not the easiest thing. Having worked in the container security space, you can instrument a container, for example, and get that visibility. You can run a privileged container, you can run a kernel modular, there's a sidecar approach, right? There's different approaches, but sometimes getting that level of granularity at the container is different than getting it at the endpoint, but you need that visibility too, because is that container, forking a process, creating a new network connection that you need to see visibility into for that baseline and for those anomalous detections as well?
Yes, and this is an area where the overall cloud things get complicated, because if you try to move a little bit further out into earlier part of the CI/CD cycles, you have the ability to first figure out that when I build my containers and test the images which are going to be deployed as a part of assembling things together, you have the ability during the CI/CD cycle to do a scan to say that what's going to be packaged and deployed in this container, all the packages, are they supposed to be like known sane? Do they have the right kind of checksums and all that? Now, you've not even deployed software. Once you pushed it out and it's been operationalized, to your point, then there is the second thing to say that as it is operational and running, what am I seeing? And can I take a baseline of that and then check deviations? So runtime versus deploy time and CI/CD is different. And to your point, once inside a container, there are organizations who run containers very differently to say that if there is anything which is unusual in a container, I'm going to treat it, potentially in a different way and shoot that container because they're not supposed to be tainted. They're supposed to be only read-only, and any behavioral change is not acceptable. Right? You're never supposed to log into a container as what someone might set as a behavioral detection. And if someone ever logs in, you know that container is tainted, as simple as that.
Right.
So to your point, yes, it is complex, but as you take it through various stages and break it down all the way from CI/CD to runtime, there is the ability to do deviation detections and behavioral detection across all these phases.
Got it. And then that ties into the last piece, right? On the protection side. And I think part of that comes in the pipeline, right? I mean, having these baselines, making sure you're getting the right instrumentation into the right element as part of that release process is one of the steps from a protection mechanism, because as you identify anomalies, yes, you might kill a container, spin up another one. But if it continues to happen, that means I have to change something over on the other side so it stops doing it, right? And so closing that loop on the protection mechanism requires a lot on the left. How much of that can you actually do during the runtime? Because I think that's where people get most nervous is, if I'm trying to make some of those protection changes in a production environment, does that then break the application, for example?
Yeah. So there are two parts when it comes to protection. Either you try to do it proactively as a part of starting something up. And one nice thing between orchestrated versions of containers and using Kubernetes and other approaches is that you can do a lot of pre-checks in place. And in some ways, they become, if you will, in the stages of the pipeline earlier, where you're trying to prevent from bad things happening by preventing something unknown inadvertently being deployed onto your infrastructure. Right? And that's the part where if you look at the protective part and you break it down into two areas, you can think of it as potential binary authorization or blocking, and the other part you can think of it as remediation, where remediation by the very name suggests that it's a post facto thing, that something has gone wrong and you're doing your best to protect yourself by stopping or killing a container. On the other hand, binary authorization or blocking is a mechanism where either due to a known lists that you've supplied, like an allow list or a block list, you have the ability to make decisions to say that, yes, I went through all the stages of CI/CD, but as a final step, I'm going to put this one extra check in there to see if this is allowed to run. And many organizations are trying to come up with more controlled environments where these containers run, as in Firecracker and gvisor and others, where the goal is to see if, despite all the checks that you have in your CI/CD cycle, how can you still do meaningful authorization and blocking. It's a part of the broader binary authorization area. And I think it somewhat works in cloud and container environments. It's harder to do so in traditional endpoint environments for that.
Yeah.
If that makes sense. I know I said a lot. I'm happy to zoom in, but we've been fortunate to have a fair bit of expertise in this area, and happy to provide a little bit more detail if it makes sense.
Yeah, I want to touch on one other point real fast, because the other thing that comes into a resiliency play, and we're seeing some more of this, is the concept of backup and recovery, right? In the cloud, that's a very interesting discussion, right? You can use different services there. Backup and recovery still has some place in resiliency from a cloud perspective, right? Because if one of my infrastructure as a service hosts gets infected with ransomware, and all my data is locked up. I mean, that's a resiliency challenge as well, right?
It is. And that depends on the spectrum and where you are in terms of an organization, especially if the crown jewels of your organization is what you run as a part of the virtual machine and container services that you might procure from a provider such as AWS and deploy the tech. If modern practices, what you try to do is that the actual virtual machine and the container itself is 100% replaceable with one instance of the other, which means if you discover that there is some tainting due to some malicious intent, which you're not sure, but you decide to shoot that container instance and start something new, you have the ability to do so. But what's guaranteed as a part of your overall config and approach is that you'll be able to reinstantiate something which can take over the instance which you just terminated. Right? Now, if you didn't do that, to your point, if you're still earlier on in your journey, yes, there is no substitute for doing a backup and recovery. The old school approach of disaster recovery implies that you may not be able to do something in one availability zone. So if you have your replicas and snapshots of storage all done right, you'll be able to reinstantiate it another place, right? But what I described still didn't cover the actual part of the data itself. And for data resiliency, despite all the best technology out there, at the end of the day, best resiliency might still come from having a backup of your data. Because if your data got encrypted, it doesn't matter whether your containers and virtual machines are going to be restarted, you're going to be locked out.
You're right, exactly. And I think that's the challenge. That's why I always love these topics around application, user, and data, because data is still a big piece in that resiliency model. And without it, yes, I can have all my cloud services up and running, but if all my data is encrypted with a ransomware key, guess what? The application's still not running.
Correct.
Yeah. Exactly.
Absolutely.
That's a lot of pieces. Is there any resources that you could point folks to if they want to learn more about how to build out more resilient cloud security services?
Yeah, there's a lot of tutorials and material out there. We as a venture, of course, are fortunate to be providing a fair bit of information here. If you're looking for improving your resiliency during runtime or as a part of your deploy time, we of course leverage open source sensors such as OS Query for providing the telemetry, and then we've open sourced Cloud Query and Cube Query for providing information from your using connectors from using your cloud instances or Cube Query providers. Between these sources, and of course, if you're interested in what we do at Uptycs, we'd be happy to provide more information, but there's a fair bit of material out there that'll allow you to build a more resilient security posture on top of your cloud services.
Yeah, it's a difficult thing to solve, so having those resources I think will be great. Ganesh, thank you so much for joining us on Security Weekly.
Thank you, Matt. I appreciate you having me here.
Oh, of course. And if anybody wants to learn more about Uptycs, please visit securityweekly.com/Uptycs. And with that, stay tuned. We still have more micro interviews left for today.